All right, so the second part of our notes here is we're going to actually get to the next question. It says, what is the percent yield of nitrogen gas if 125 grams are actually produced here? So here's what you want to take a look at. Earlier on, we did all the stoichiometry and we ended up getting our theoretical yield, and we came out with the smaller of the two numbers here. So between 131 grams of nitrogen versus 182.7 grams of nitrogen, we said that 131.1 grams of nitrogen was our theoretical yield. So again, if the lab or the experiment were done perfectly in a perfect world with 100 grams of N2H4, we could make 131.1 grams of N2. But if you look at the question, it says, what's the percent yield if 125 grams are actually produced? So this is what you guys would do in a lab. You would go into a lab, and during the lab, you actually do the whole thing. And then at the end of it, if you guys weighed how much nitrogen gas you actually got, this particular group here got 125 grams. So you really got 125. So this is your actual. You were supposed to get 131. So on the next slide here, we're going to go ahead and calculate that percent yield using that very simple equation that we saw on or in the very, very early part of our notes over here. So let's take a look at how to calculate percent yield. So percent yield is always the same thing. It's your actual yield divided by your theoretical, and then you go ahead and times it by 100. So remember that our actual yield, according to the problem, they told us earlier that someone really made 125 grams of nitrogen. But then from doing our stoichiometry setup earlier, we saw that theoretically they were really supposed to get 131.1 grams. So you take these two numbers, they get divided, and they're going to be pretty close to each other, right? You're not going to get someone getting something like 2 grams of nitrogen when they should have got 131. And then you times it by 100, and they did a pretty good job. So in this lab here, or in this experiment, someone got 95.3% of the nitrogen gas they were supposed to get. It's not perfect, but anything I would say in the 90s range is pretty good for a lab that we are going to do. So this Friday, you guys are going to be doing a limiting reactant lab with hydrochloric acid and then some zinc. And you too will be calculating out what the percent yield is from what you actually really made in the lab versus theoretically how much you were supposed to get in the lab if, everything went perfectly. Okay, so the second setup, we have another a way that a question could be phrased here for percent yield. It says, if the yield turned out to be only 86.5%, okay, so this time somebody did the lab and only 86.5% of what was supposed to get made was made. It says how many grams of N2 would be actually produced here. So if you go back here and look at our original equation, ooh. So if we look at our equation that we have right over here, and this time around, if we're going to be manipulating the equation, you know the percent yield. Okay, it's 0.865. Okay, notice how the percentage was turned into a decimal to make it a little bit easier. The actual yield is the thing you don't know, so that becomes your x right here. The theoretical yield is still the same number that we got earlier. So remember how we got the theoretical yields of 131.3, or sorry, 131.1. Okay, so you're going to go ahead and plug all this into an equation. Again, since we turned the 86.5 into a decimal, we don't need to use this times 100 part right there. Sorry. And then we end up with this setup right over here. So we have 0.865, this is our 86.5% turned into a decimal, is equal to your actual yield. We don't know what it is, so we're going to put an x there, divided by the theoretical, which is 131.1. And to get to our answer here, all we're going to do is just multiply. So we're going to take our 0.865, we're going to just cross multiply it with a 131.1, and then you wind up with your X, which ends up as 113 grams. So somebody did this lab, and again, they got a percent yield of 86.5%, and that means that they really only made 113 grams instead of 131.1 grams. Perfect. Okay. Okay, so I think I told you guys that if we go back to the original problem, I'm just flipping back so we could actually read this problem. I already told you that this very last question right here where it says how much excess reactant remains, this is actually the hardest question to answer for most people. So I'm going to cover it in the screencast with you guys today for the notes. But when I meet you guys, or when I see you guys tomorrow, which will be Wednesday, we're going to actually cover this again. So if you feel a little confused today, it's okay, but just try to follow along with the steps. And one reason why this might be a little bit difficult to do is that there's more than one way to do it. So you kind of pick and choose which is easier for you, but we're still going to do stoichiometry. So this very last question that we're looking at here, it's asking, well, first of all, from doing all of this, we figured out that, remember how we said N2H4 is our limiting reactant. So this is going to limit how much product we're going to actually make. Okay, and we said that N2O4 was our excess reactant. So this is the one that we have too much of. Okay, and what they actually want you guys to calculate right here is, hey, from the 200 grams that we used, how much is going to be left over? Because we know we don't use all the 200. We're going to be using a smaller amount than the 200. So it's saying how much of the N2O4 is actually left over. Okay, so let's look at some different ways that we could actually set this up. But again, please remember as we do the problem that the N2H4 was limiting and the N2O4 was our excess. And then again, our B was the nitrogen gas. So remember, we were solving for the nitrogen for the end. Okay, so let's take a look at the actual calculation setups here. I'm just skipping over all this stuff that we already did. So to look at our chemical equation again, right? And this you already wrote down. These are the two stoichiometry setups that, again, we already did. And one more time, the N2H4 is your limiting reactant. The N2O4 is your excess reactant. And we're trying to figure out how much of this of the 200 grams is actually left over. Okay. So here's one way you could do this. So this is the very, very first way that you could do this problem. We earlier solved for 131 grams of nitrogen. We said that this was our actual theoretical yield. And then with the 200 grams of N2O4, it says that we can make like 183 grams of nitrogen. But if you take these two numbers over here and you subtract it, if you take your 182.7 and then you subtract out the 131.1 grams of N2, right? If you guys do that step right here, this is going to actually be the amount of N2 that does not really form, right? So we know that we're supposed to get 131 grams. And then if we had a lot of this N2O4, we would get 183 grams of N2, but we don't really make that much. So if you took these two numbers and you actually just subtracted the smaller number out from the bigger number here, we would end up with a setup like this. So let me show you what we're doing here. So the 182.7 subtracted from 131.1, that actually gets us to the starting amount right here of 51.6 grams of N2. So this is now my A in the reaction. So let's write it up here. Once I subtract out the two numbers that we got earlier from doing the stoic setup, if I subtract that, that's going to now become my A. Okay. And look at what my B becomes. My B is going to be the excess reactant. So the N2O4, which we know we're going to have left over, we're going to solve with 51.6 grams of N2 that never really formed. Again, we got that by subtracting these two. We're going to go through all the stoichiometry roadmap here, and then we're going to get to grams of N2O4 for your final answer here. And guess what this is? This is your excess reactant that is left over. Okay, so what you really have to be careful for in these limiting reactant problems is knowing your A and your B. Okay, so in this very, very first way that we're looking at here, again, your A is your B that we started off with earlier. So we got the 131 and then the 182.7, we subtracted that. And this right here, the 51.6, once we subtracted it, the 51.6 grams, that becomes my starting A. And we're going to go through and solve for, hey, how much of this excess reactant do we actually have if we use 51.6 grams of N2? So that's one way we could do it, by going from A over to the excess for B, okay? And that would be the answer. It was the answer that you guys saw over here, the 56.5 grams of N2O4, and that would be your final answer. Now, there are other ways you could do this problem as well. So I'm going to teach you guys 2 other ways you could set it up. From the 3 options that I give you, pick the easiest one for you, and then you could try it. But it doesn't matter which one you pick because they're all going to be the same thing. So again, this is our chemical reaction, and the question is how much excess reactant is left. Okay, so here is another way we could do this here. So remember how this 100 grams of N2H4, remember how earlier we said that this was our limiting reactant right here? Okay. What we could do is we could say, hey, I know that the N2H4 is going to run out first. Like, I don't have enough of it. I'm going to try to figure out how much of the N2O4 I actually need to react with the N2H4. And the setup here is that the N2H4 is my limiting, the N2O4 is my excess. And we determined that from, you know, all the work that we did way early on. Okay, so we're going to go from A to B over here and solve all the way through. And then we get this number right here, 143.6 grams of N2O4, right? But remember this, we actually had initially more than the 143.6 grams. They gave us 200 grams of the N2O4 to actually use. So if you wanted to know, hey, how much of the excess reactant is left over, what do? We just subtract these two numbers. So we do 200 grams minus 143.6, and then we would get our final answer right here again, 56.4. Okay, so in this setup that we just did together, the subtraction happens in the second step, like this step right here. The subtraction is done after you do the stoichiometry. If you remember the first way I did it with you guys, we subtracted first and then did the stoichiometry. And again, pick whichever way is easier for you. I think a lot more people find this method a little more like intuitive, like it makes a little bit more sense for them as to what they're doing. So that's one way you could do it. Okay, so this shows the N2H4 pretty much running out. So that going all the way down to 0, and you're just calculating how much N2O4 you need to react with it. Another way you could do this calculation is this. So remember how earlier on from doing all the stoich setups, the very, very first step, remember how we went through and we calculated that we're really going to make 131.31 grams of N2. This was my theoretical yield that you solved for. Okay, so in the second scenario, let me actually do the second scenario in a different color so it's a little easier to differentiate between what we just did. We'll do that one. So